have that power? Okay, good. So, welcome everyone to the last meeting of the year for our Lean Prover community slash Mathlib meetings. Hopefully everyone is enjoying the holiday season and not getting overwhelmed by it. The holidays are always a good time to take stock of what's happened over the past year and also look forward to what things could or should happen in the next year or maybe even beyond. So maybe to start off with, it'd be good just to hear from people about some of the things that they were really impressed by or that they really enjoyed or they really found valuable that occurred within the community over the past year. There's many things to choose from. I think I'll start by offering the creation of the Mathlib initiative. I'm not sure around this time last year if anyone predicted such a thing in terms of their New Year's resolutions. But it's been and it will be an incredible positive force for the community to help keep the library moving forward and in a healthy state. So that's what I'd like to highlight. So let me open it up to everyone else this year and see if anyone else has some favorite things from the past year.
Well, let's add to that list the creation of ICAR.
Yeah, that's
similar comments apply.
Yeah, it's
although people might have seen it coming a year ago.
If you're on the proposal, if you'd hope that it would happen.
Right.
But that's also a great thing. And since we mentioned it, if you happen to be in Washington, D.C. on the week of January 5th, perhaps for the joint mathematics meetings that are happening there, please stop by our booth on the Exhibition Center and stop by the Institute's open house to chat with us, talk a little bit about what ICARM is, what it can do, and learn more in general about the math institutes that are supported by the NSF. So, all right, let me turn it back over to anyone else who wants to highlight things from the past year.
So another item is, I guess, all the IMO medals that AI agents received, or well, I don't know if they received a medal, but they achieved a medal performance.
They seem pretty happy if you tell them that they did a good job. So. And then, within the past few months, we've had an avalanche of Vibe formalization tools, right, that have been either advertised or explicitly made available through API to the community, like Aristotle. And I can report that it's having an effect far beyond the people who usually use Lean as a semi-daily language or more. And that a lot of mathematicians are viewing this as an opportunity to engage more deeply with formalization, with Lean, with Mathlib, because that barrier to entry has been reduced. As we know, there's still a lot of gotchas with using these things, but already the things that they can do are very impressive. And over the next year, I don't think anyone really wants to bet on them not dramatically improving over that time.
So another really cool achievement is the funding that the FRO got for creating their mathematical workbench team. And another thing that came to mind was the completion of the Carlson project and the new ERC grant that the Bonn crowd now has to sort of build on top of that.
No, that's great. It's really wonderful to see formalization being interwoven with actual research in a reasonable time frame, right? That's always been the dream for 60 some years, that you would get to a point where it wasn't such a drain on productivity to sit down and formalize stuff, where you can actually just find value in it as a net thing if you're just a regular math researcher off the street. So it's great to see those kinds of things happening. Anyone else have highlights that they would like to?
How old is the formal conjectures repo?
I was just going to say that. I was just looking up. April 8th is when the first commit, the first public commit is on GitHub. So yes, this year.
Also this year. Cool.
I think it's a really cool place to put. There's a standard place to put open problems, and perhaps have lots of diverse attention directed at those problems.
I think it's also going to be an extremely important resource, because we're seeing lots of spam on Zulip, and people are also receiving spam on their personal email of people claiming that they have formalized some really big conjecture. And if they don't use the statement that is in formal conjectures, then I think that's great evidence to just stop paying attention to the rest of what they've written. And yeah, so that's going to be a key function. Like Matt just mentioned that these 5 formalization tools will improve drastically. So I think the amount of such claims that we'll be seeing will also improve drastically. And for the foreseeable future, I don't think we have any reason to believe that these tools will formalize the Riemann hypothesis. So yeah. And of course, like with the Riemann hypothesis, everyone has to be skeptical. But they also make other claims. And I really think the more we have vetted statements of formal conjectures, the more valuable that resource will be.
No, I 100% agree.
All right, Sneer posed something in the chat. Yeah, right. The equational theory project was also, well, I guess the project was finished quite a while ago, but they finished writing the paper like last week, I think.
Yeah, that's a testament to massive collaboration scale, I think, that's enabled by these types of tools. So it's great. It's great to see that. And I wonder what comes next in that space, like massive collaboration involving people across diverse backgrounds with lots of interesting ways to attack the question. As a mathematician, you got your set of tools, and you pick up your hammer, and whatever you see is kind of like, is this a nail? Is this a nail? Is this a nail? And maybe I say, oh, this isn't really a nail, but it's kind of nail-like, and then my hammer becomes hammer-like, and then I can solve that question. But it's great to see and get input from people who have really dramatically different perspectives and have almost disjoint skill sets in some ways for these things. I mean, there's been a lot of work on the core language itself, right? With did async collaboration land this year? Is that, am I misremembering?
It feels like async is already quite a bit older.
Okay. Well, the module system. I mean,
Certainly
I
the
view,
module system.
yes, I view both of those as sort of two sides of the same coin, in that if you want the language to be performant or more performant or optimally performant, right? These are things that you have to do, but they're huge lifts, right?
Yeah.
Where you have to go in and you have to pull apart the guts of the language itself and put it back together in a way that, you know, works for everyone downstream, including Mathlib. So, yeah. And grinds, yeah, it's very good. So Sneer mentioned that grind is another example of huge amounts of efforts from the FRO at improving the lives for all users. So yeah, that's a fun one too. We'll see that, I think, continue to become more powerful in the new year. I just saw in the RSS feed Leo pushing commits, fixing things in grind. So that's another really really fun thing that's come up for the past year. Anyone else have any favorites from the past year?
Hello, can you hear me?
Yeah, we can hear you.
Yep.
This is Yang from China, and my Zulip account is Nick Hadford. And I have a question that should Mathlib cut the use of ASOP, or I may think that the ASOP in my code has really slow my code. It is that I can show something. Can I show my screen in this Google meeting?
Well, it might be easier to debug questions on Zulip.
Okay.
Yeah.
It is that in my code that I use Aristotle API to fix my code, and it returns me a lot of ASOP, and I may think that ASOP make the code hard to read and hard to use. I want to the code is for the formalization of a paper about Allen's combinatories, and I may think that it may be good to post it to Mathlib, but I may think that there must be some standard for Mathlib, just like that I should write my comments on what my code is writing, and if I write too much more ASOP, that will make other users hard to understand what I'm writing. So I have a question that should I cut the use of ASOP?
Well, I think that is a decision that's sort of made on an idiosyncratic basis, depending on your own particular situation. Certainly throughout the library, there's places where ASOP does seem to drag a bit more than other areas, but it's a very useful tool too. So I don't know if this is the best venue to debug code. Right, this is not necessarily.
Okay, I can post my Zulip here. Have a post.
Okay, so let's take that question off onto Zulip.
I mean, I definitely agree that code from Aristotle is not optimal. Like it's pretty good at proving stuff, but the proofs can be like 2 or 3 or 4 times longer than a fully reduced human written proof. And maybe a desire for improvements next year or a wish list for next year of provide proving tools that produce beautiful proofs rather than just proof things at all. Johan, you're muted.
Yeah, I was saying, or provide proof improvements, or provide gold
Improvers, yeah, call for the reducers. Or
Is anyone working on that? Do we know of?
So there was this tool called Improver, right? Which I think.
Yeah, Riaz, undergraduate, is working on that, and Sean Wellock.
Right.
I think they have like a publication, that submission about it that works. And I know that like when I've been talking with Math Inc., like they talk about, oh, we have the prover agent and we have the golfer agent. And I've seen some evidence in the Aristotle proofs that I got back that like there are lemmas that seem like they're going to be useful for like the final proof, but then like they just don't get used. So that tells me that there's evidence that like they used the lemma at first and then they golfed the use of that lemma out of the proof somehow. But I don't know.
Mm-hmm.
I'm just looking back at the, let me see if I copy the link and drop it in the chat. This is I gotta figure out where the chat went. There it is. This was the predictions from the meeting around a year ago.
Ah, interesting.
So we can see how much, it was a fairly short list that was summarized here at least. And I guess the first one there is alpha proof or open source alternatives. But, you know, it's similar enough to say API access to Aristotle would fit that one, right? So I'm willing to be generous and say that that prediction has come true. Mathematical milestones, we have 2 listed. Classification of semi-simple Lie algebras.
The year isn't over yet.
Yeah, the year's not over. There's been a good amount of progress on that question, I think, as the year's gone on. But I think it's fair to say that that has not been completed. And then differential forms in de Rham cohomology.
It's not in Mathlib yet.
Is it in someone's branch somewhere?
No, there is a repo that defines the differential. So basically, the Rham cohomology would be another 20 lines or something.
Okay.
Yeah.
Okay. That's pretty good. I mean, again, I'm willing to be flexible here. So landing in Mathlib. Oh, geez. If we didn't have that qualifier, I think we'd be pretty set here.
Yeah.
And I guess what else we got? We have formalization of Morse theory. I don't think we're anywhere close to that. That'd be one of my favorite things. I always like Morse theory. This next one, advances in differential geometry, smooth manifolds, and analytic spaces. We had Riemannian manifolds land, right? That's another great one. And so I can easily check that one off. Hodge structures.
Nope.
No. Okay.
Nothing.
Yeah. That's too bad. That's too bad. That's a nice thing.
But the next one is we have some progress there.
Yeah. Well, we have a lot of attention devoted to partial differential equations and functional analysis over the past year. I think there's a lot of interest in these from the outside. And then also people who are in Mathlib have been around for a while would love to see developments like this. And so,
well, there was this workshop, right, at MSRI.
MSR or SL Math ICARM joint workshop. Yes.
Yeah.
Where Remy Dijen and Michael Rothgang came in and talked to the ongoing thematic programs, both of which are PDEs of different types, and introduced them to formalization and then helped some groups start projects. And so with that, with some of the Vibe formalizing tools, I think if you want to make a prediction, recycle this prediction into saying, oh, we'll have a solution to a PDE in Mathlib by the end of the year, 2026. I think I'd be pretty comfortable making that prediction.
Mm-hmm.
So improvements in the lean review process and in dashboards, I think we can say that has been achieved. Again, thanks to the Mathlib initiative to a large extent, but also the efforts that fed into that beforehand.
Yeah, but we're nowhere close 1,500 plus pull requests per month.
No,
That will still take a bit.
no, that's a tall order. And then as Johan mentioned, multiple AI entrants in events like the Mathlympiad. Well, entrants, I think I think it would be safe to bet that we get multiple gold medals from what we already seen with alpha proof and alpha geometry in 2024. That's an easy one. Progress on the Infinity Cosmos project. I think there has been progress. I think they already they have the buy category of let's see if my terminology is correct. The buy category of Infinity Cosmos. Oh, Zoel can. We can't hear you though, unfortunately.
I think it's the buy category of quasi categories.
Is it?
Can you hear me now?
Now we
Yes.
can hear you. Excellent.
Yes, so there was some progress. So there is the strict B category of quasi categories, which was achieved quite. It was achieved quite a few months ago, but it entered Mathlib, I think, a few weeks ago, and so it's unclear. There are some design choices, directions. I'm not completely sure which direction it is going to now, but it will benefit from some of the results about quasi categories will benefit some work by Jack McCoon and myself about the closed monoidal category structure on quasi categories, which are so it's somewhat related to work that I have done and refactored recently about the basic homotopy theory of simplicial sets, for which I have formalized the model category structure by Quillen, and some of the material that I have developed recently will be useful for this Infinity Cosmos project. And it's unclear, from my understanding, whether Emily wants to develop the Infinity Cosmos side, the very theoretical approach about Infinity Cosmos, I cannot say what it is, or to focus more on B categories and quasi categories. So maybe they will go in both directions. It's unclear.
And while you're here, I should say that we could have a whole episode on all the work you've done around category theory. So
this year I have worked. My main focus was the model category structure on simplicial sets. First, I developed the model category structure on topological spaces. So it's about proving axioms set up by Quillen some decades ago, and then do that for simplicial sets. And basically, proving these axioms is a way to say that we can do homotopy theory in a certain sense with topological spaces or with simplicial sets. And in the future, so it's to have these model category structures is really the basic step if we want to do more homotopy theory. So there'll be some more applications, but to get these axioms is very technical, but it's a very important step in order to do anything else in the theoretical side of what we call homotopical algebra, to have examples of categories where we can do homotopy theory. So I have developed this proving the axioms, and I've also been working on the general axiomatic side on the what we call homotopical algebra. And it also intersects with derived functors in 1, 2, several variables. And there is a unique framework in order to deal with derived functors, both in homotopy theory and in homological algebra. So in maybe not hopefully within the next year we could have the notion of a good notion of Tor. I mean that this year there was this year there have been already some applications of Ext, like in categories of abelian groups of modules, and it has some applications to there was application to formalization of local algebra, like Gorenstein rings, Cohen-Macaulay, a lot of things which kind of requires Ext. Maybe within the next year we can have also Tor. So it will require some theoretical work and also a lot of abstract nonsense pull requests, but eventually there will be some improvements and we can have more applications. And since I am talking, I would also like to mention some achievements by the few young people working on algebraic geometry, like work by Andrew Young and Christian, etc., about étale morphisms, étale site, faithfully flat topology, FPPF or FPQC topology. So this is quite impressive. I've been following that from a certain distance, and I'm very impressed with what they are doing.
Yeah, didn't we just have Andrew post about the formalization of Zariski's main theorem? Right?
Today, yes.
No, not in Mathlib yet, but coming soon to a clone near you. That's
Maybe
wonderful.
here.
Oh, anyone have any other highlights from the past year? I'm 100% sure there are many things equally as impressive to the things we talked about that are slipping past our memories. You know, there's been a lot of developments.
Maybe we should start looking ahead.
Yeah. Okay. So we've heard some predictions for the upcoming year. Mathematical, AI, and otherwise. Do people have any other predictions? I think it'd be good to start with mathematical topics, perhaps. Like you will see something in Mathlib. So we mentioned Tor between modules. We've mentioned a formalized solution to some PDE in Mathlib. What else do people think is within the 1 year time horizon for math landing in the library?
I guess we'll get the Jordan curve theorem in any dimension proved with singular homology.
That'd be nice. Yeah.
I mean, the complement of a topological sphere has two connected components, exactly two connected components.
That'd be very nice. And you don't have to stop at one mathematical topic. You can volunteer as many as you like.
Okay, what about curvature and geodesics in Riemannian manifolds? That's not PDEs, but that's ODEs in a complicated geometric setting. So there is a lot of interesting things to say about that. I think we're just on the edge.
Yeah, that'd be great. I'd love to see that. Yeah, I mean, it'd be wonderful if you could put the PDEs together with the geometry and do some, geometric PDEs. I don't know. You can,
Conjecture is maybe not next year.
yeah, that's, well, can be the ultra optimist and say that the tools that we have will develop far enough that, we will be, proving results on,
But
ability, like K stability or something.
even
Mathlib.
the classification of two-dimensional compact orientable surfaces using the Ricci flow, I'm not sure we'll see that in Mathlib next year.
That'd be fun. That'd be really fun.
I'd love to have the classification of surfaces by any method, by Morse theory,
Mhm.
by hand and triangulations, by Ricci flow, by whatever method. But I'm not really confident we'll get that in Mathlib next year. I hope to be proven wrong, of course.
So Artie has his hand raised. Artie. I'm not sure we can hear you if you're talking. Okay. Well, the mic's not working, so feel free to post what you want in the comments, and we'll repeat it out here out loud for everyone else.
So I'm not sure if I can make this a prediction, but I would love to see some sort of K theory in Mathlib next year.
I mean, don't we have like the Grothendieck group of some triangulated category?
I mean, I guess we can get a first definition
Yes.
very quickly, but yeah, then maybe we also want a little bit of theory about it.
So actually, on some draft branch, I have a formalization of Quillen's Q construction and of exact categories. So in principle, we can have definitions because soon we shall, I mean, maybe not, probably within the next year, we can have the good homotopy theory of simplicial sets in Mathlib. But then in order to prove any serious theorem about K theory, we would need to prove Quillen's theorem A or B, which require slightly more homotopy theory. So we can easily have definitions. Just K0 would be easy, but to have even higher K groups, but to prove anything serious about it, we would need much more homotopical developments. So maybe not for this year, but within 1 or 2 years, maybe we can do.
Yeah, I mean, I'm willing to bet that when we make this recap in about a year at the end of 2026, I think we're going to exceed the expectations mathematically that we had compared to the 2025 one. I just think so much is out there, so much momentum is built, and the tools will improve. People will figure out ways to use them in productive, more Mathlib idiomatic ways, and do some really interesting things with them. So I already mentioned in the chat algorithms in real algebraic geometry, like the cylindrical algebraic decomposition algorithm. Yeah, that'd be cool. One of the things I'd love to do is I'd love to have verified mathematical algorithms that actually generate computable code for things I care about mathematically. I mean, if you're really pushing the boundaries for doing computation, Lean's not the language you're going to reach for. Get to the bleeding edge. But for a lot of the stuff that's done, you just want to be able to produce a number for an example that you care about to get some intuition about what's going on. Yeah, we don't have computable polynomials, but there are many ways around that. So, and it doesn't necessarily have to be about algebra itself. But anyway, I'm not going to make any predictions about that necessarily. Tate's algorithm, yes. And it's wonderful that we can talk about these things within, with the reasonable amount of, uh, what's the opposite of being disingenuous? Is it ingenuous? Genuineness, I guess, right? Good faithedness. As always, English language fails you when you're in front of an audience. But, having conversations where these things are, reasonable targets is really exciting for where things are headed. So here's a more question than a prediction. Will we have a publicly available vibe formalizing model that will actually output Mathlib idiomatic code? Anyone want to take the pro or the con position on that for 2026?
So okay. Do you want to make it a bit more precise? Like, will the typical output be Mathlib idiomatic, or will we see some examples? But
Yeah. I think some examples is, what is this pass at? I would like. This doesn't really quantify it, but if you could talk about the number of PR requests that we have that are Mathlib idiomatic, right, or close to it from their initial push, what percentage would you say that was? I think it's pretty high.
Anyways, like I think we'll definitely see examples of AI generated Mathlib idiomatic proofs. And I'm willing to take this side that it will even be regular, like reasonably common.
I'm worried that the perception is that all the glory is in just proving things, so that's what we'll be invested in. So maybe I raised the question: how can we incentivize the people developing these systems to make idiomatic code?
I mean, the obvious thing I think is to have a competition where, someone judges the output and says, "Wow, you're the smartest model on the planet." Because the mathematics validation for mathematicians ain't nothing these days for the labs, right? Mathematicians are smart, at least as perceived, and then doing good mathematics. So that's one way. I don't know. I'd like to hear other suggestions on this, because I don't see a whole lot of, like, competitions are good, but people take the shortest path to things. So, anyone else have any suggestions about how to incentivize community useful behavior from the models and the tools we use? Artie? Focus on AI assistance for existing theories rather than definitions, type classes, etc. I think that's a lot of what we have right now, although I've seen reports sporadic on Zulip that of, say, Aristotle creating definitions in the process of formalizing things. But I don't have any personal experience to gauge whether that's a thing I should regularly expect, do it effectively, or whether it's a pleasant surprise when it does happen. Yeah, Artie is skeptical about having well-designed reusable code globally in terms of design of, a particular definition or class that inherits a lot of API, building things out in a very structured fashion.
On the other hand, as like most human contributors are struggling already to keep the entire library scope loaded in their working memory, whereas AIs that are trained on all of Mathlib sort of might at some point become better at this, like might be more aware of everything that's out there in Mathlib and things to take into consideration when designing APIs, things to hook together.
Mm-hmm. Well, I've always been curious about, when you take any particular mathematical structure and you embed it into something, you tend to make certain symmetries or properties much more manifest, much more easy, much more obvious in that particular representation. And so when you stick all of math in lean, right, there's going to be the representations in lean of mathematical topics that are a lot closer in terms of the semantic distance of their code, syntactic distance, I guess would that be, compared to like the mathematical distance between them and their use in usual mathematics. And so I wonder how much of there is that type of behavior, and what can we learn from it in the end.
Mm-hmm.
Another aspect that I think is real fun, but I'm a little less aware of, and well, maybe just the one I'm a little less aware of is the use of Mathlib in other domains, right? Not necessarily just training AI models, but you have, much like AWS's SAMP cert project, we formalize differential privacy, right? You have complicated mathematics going into algorithms, other code, right? Where are we going to see really high-powered advanced mathematics formalized in Mathlib popping up in projects outside of it that aren't purely formalizing mathematics? And I'm sure if we had the right audience here, there'd probably be people who would point out existing projects on their way that are doing this kind of thing. But I think that is a significant part of the existence of all these companies that we see that are intent on formalizing mathematics, right? Is to see these applications so that developers have this large library of formalized math. They have the tools to interact with it. They can build code that's safe from the start in a productive way.
I guess maybe the most obvious domain is cryptography.
Yeah, it'll be interesting to see when the elliptic curve branch of algebraic geometry meets up with the sheaf of points branch, or sorry, the functor of points branch. Right.
Right.
I've also seen that there's work on physics and chemistry even, but it can also be a bit surprising how much work is needed to sort of even start to meet up, right? I mean, for example, like figuring out how to handle dimensions, right? And dimensionality, and make numbers dimensionful, right? It was a big challenge, and it's not something that Mathlib sort of concerns itself with at all, but it's fundamental to this other sort of application of math, right? Yeah, it seems like there's a lot of I wonder how much fundamental work in general, how true that's going to be over different applications, right? Is it going to be like, okay, every time you want to do another application, have another application, you need to sort of do some foundational work to bring it, so it can meet up with Mathlib in the first place.
Yeah, I mean, I guess for a lot of these things, can we abstract notions like even further out? Like maybe I don't even care about my implementation of a polynomial ring. Right? Maybe it's just a class from now on. That it's just the universal, commutative algebra over this field and satisfies those properties. And you bring your own implementation. It'll be interesting to see what shows up and drives that kind of thing. And I guess we talk about things downstream of math, and we should talk about CSLib, which is, the start of that is another huge achievement over the past year. It'll be interesting to see in 2026, at the end of 2026, what CSLib looks like. Right. In a lot of ways, it's kind of like, what if Mathlib started in the age of artificial intelligence? How much does it get shot out of that slingshot at the end of a year, and what's the development speed? Is it accelerated by these kinds of things? So to make it concrete, how many lines of code do you think CSLib will have at the end of 2026? A million? I see people shaking heads both ways. I like to be the optimist. I say, yeah, let's take the over on that. But I could, see it going the other way too.
It goes up and then goes down because we find the right way to do things, and they're not. It's always easier to write more code than less code, right?
Yeah, that's true.
If we find the right, sort of abstracted notions for things, maybe we'll have less code that does more.
So here's another one. How much of the classification of finite simple groups do you think we'll see formalized? Doesn't necessarily have to be in Mathlib, but formalized by the end of the year. All right, there's a series of books that contain the corpus of the classification. Because, that's one of the things that mathematicians kind of, with the view towards formalization as a means to make sure that fiddly details are correct, not so much explore ideas, tend to identify as a particular thing, right?
Well, I guess one question is, where are we now? Johan mentioned earlier, people struggling to maintain the scope of Mathlib in their working memory, and I certainly fall into that here. I'm not sure sort of where, how far are we? What's left to be done?
I think 1% is done. So we have the statement in the formal abstract. So I guess it's even lean free code in the formal abstracts repo. And then of course, like in ROC, the order theorem, I'd say that's like 5%, maybe 7%. So yeah, loads of work to be done. If we're optimistic, I would say we get 20% done next year. I feel like I'm optimistic. I feel like I'm optimistic if I say 20%.
I think that is optimistic. I agree, but I don't think it's outside the realm of possibilities.
No.
Oh, will downloading and unpacking all the oleans be faster or slower than they are right now at the end of 2026? I have, again, I'm optimistic. I think they actually would be faster. I think this is the path that FRO has been on, and I think we'll see it pay off. Now, of course, maybe there's, if I really want to like force everything, then the answer is probably going to be no. But if I'm opening up, one thing in the middle of the library in terms of the dependency graph, I think it'll be faster. And by a reasonably good amount at the end of 2026.
Is that something like the module system enables, like partial downloads?
So my wife says that I tend to not listen and impose my own perceived reality upon people's actions and conversations. But that's my sense, is that you want to have a really modular way to get all the build artifacts for the things that you need, right? I mean, if all this expose this, don't expose that, it's just to make sure that we don't have to keep track of all the stuff that we don't actually need to run things in a current file. And so right now we still need all the oleans, but you can imagine, well, once I've figured out what a particular file needs, then I only have to pull a smaller amount down if I'm working with that file.
Well, there's like only getting the files you need, and there's also like only getting the types of items rather than their full terms. I think those are maybe orthogonal, and I don't know which of those will land.
Well, I think figuring out the files would probably be easier than figuring out, like, inside a given olean how to pull out the stuff that you need. like partially unpack it in some way, might be the way to go. But we'll see. Like I said, I'm hopeful. All right. So we got 5 minutes left. And since this is going to be out on YouTube and people might stumble upon it, because, such an interesting thing these days. Let's say you're someone who has tons and tons of money, right? More money than you know what to do with. Where should you put that to maximize development of formalized math in the year 2026, right? So you have unlimited resources. You can conjure up developers, right? Compute, but you just need to figure out where to focus them. What tasks should they be doing? And what's the end goal that's reasonable within a year's scope? That at the end of this time, people will be able to step in, like the mathematical community in general, be able to really step back and say, wow, that's an incredible accomplishment that's been done.
I would say lowering the barrier of entry, so invest in that, and invest in scaling up the review process, because many more contributors means many more contributions, but these somehow will need to be reviewed and will need to be integrated. I'm not saying Mathlib per se, but also if you contribute to any other library, it has to be integrated into the ecosystem, and so some component of review needs to take place. And the more efficient we can be about that, so the more automatic quality control, etc., the better.
What's your wow factor for the mathematical community at the end of that? I 100% agree with what you say, because that's that's the sensible thing. That's the thing that will actually bring about all those eventual developments.
Yeah, I think like this will have long-term impact if you invest in this. And I agree that sort of the review thing, like review doesn't have to imply human review. Like humans should be in the loop, but we are already, like, there's lots of CI review happening. If we can scale that up and lower barrier of entry, then you'll really have a multiplier effect. Could be orders of magnitude.
And so for me, there's like a few, there's certainly a few math projects that are like within reach now and were not a year ago, that could settle the status of some of the recent math developments over the years. So I mean, of course, there is the ABC conjecture with Mochizuki, where things actually seem to be happening on the lean side. I personally don't think this is happening in 2036. So I don't want to mention that. But Bavik had mentioned a much closer goal, like the existence of designs by Peter Kivash. This is a huge amount of work, but it's the sort of use that we are able to manage nowadays. And I could see ourselves like just take it as a community project over the coming year and be done by the time we enter 2027. A more personal project of mine would be something less controversial. Like whose validity is less controversial, namely Zermelo theorem. There's still 5 proofs out there that want to be formalized, each using a different area of mathematics. And I would like to try to formalize them mostly automatically using something like Aristotle or AlphaProof, with as little input from me as possible. That would be something I want to try.
Those sound fun too. Yeah. Earlier on we were talking about all the really amazing things that are, just just out there on the horizon that you wouldn't be able to say at the end of 2024, right? Where we are right now. If I had all the money and all the developers, I'd formalize the whole lean to binary translation. Right. So, formalize compiler, formalize all the way down. And I would think that would be pretty awesome and pretty useful. And also make people want to use lean a lot more in the end. Maybe not mathematics per se, but I think it would create a lot of interest, which would, in the end, lead towards things like that. But other people took some good ones, so I had to do something else too. All right, so that's a little past the hour, so we should probably wrap it up. I want to thank everyone for joining me. It's great to see so many people and hear so many perspectives on where we've been and where we're going. I think we get a summary here, and I'll try and post it again in the Zulip chat, some of the predictions and some of the highlights. And hopefully people who couldn't make it can jump in and point out the things that they really appreciate over the past year, or that they think will be on the horizon for the next one. So with that, enjoy the rest of 2026. Enjoy the holiday season. We'll be back in February.
Let's first enjoy the end of 2025 before we enjoy.
Oh, sorry. Yes. Yeah. Sorry. I've already spun forward in my brain. Yes. Thank you. The end of 2025. All right. Everyone take care. I'll see you on Zulip and elsewhere.
Thank you.
Happy holidays.
Thanks.